Hello everyone, welcome back to our channel Problematical. Today we'll continue our discussion about Chapter 2 Polynomials from Class 9th Maths NCERT. The topic of discussion for today is zeros of a polynomial. We know that we represent a polynomial by p of x, q of x, r of x, some variable of x. Let us consider one polynomial as p of x is equals to x cubed minus 2x squared minus 3x minus 2. X is a variable over here. We know that this is a cubic polynomial from our last class's discussion. Because it is a cubic polynomial, it will have degree 3. The highest power that x can hold in amongst all the terms of this polynomial is 3. Hence, the degree of the complete polynomial will be 3. That means x can have 3 different values. This is the topic of discussion here. For example, if I take x as any random value, let x is equals to, say, minus 1. What happens? We can calculate p of minus 1. What you are supposed to do is replace x by minus 1 in the complete equation on left-hand side as well as right-hand side. Wherever you find an x, just replace it with minus 1. So minus 1 whole cube, minus 2, minus 1 whole square, minus 3, minus 1, minus 2. This is minus 1, minus 2 into minus 1 square is plus 1, minus 3 into minus 1 is plus 3, minus 2. Minus 1, minus 2 into 1 is minus 2. So this is minus 1, minus 2, plus 3, minus 3. Minus 1, minus 2, minus 2. This can be written as minus 5 plus 3, which is equals to minus 2. So when you placed x is equals to minus 1 in your given polynomial p of x, you got the value of minus 2. This minus 2 is said to be the value of the polynomial at a particular value of x. So at x is equals to minus 1, the value of the polynomial p of x is equals to minus 2. This is the value that you got. Now, what if you consider another polynomial, say t of x, as x squared minus x minus 2. Let us take x is equals to 2. If you place x is equals to 2 over here, let's see what we get. At t is equals to 2, you'll have 2 square minus 2 minus 2. 2 square is equals to 4. Minus 2 into minus 2 minus 2 is minus 4. You're getting a 0 value. T of 2 is equals to 0. Let's consider another example. R of x is equals to x cubed minus 7x plus 6. Let's substitute x is equals to 2. So we'll get R of 2 is equals to 2 cubed minus 7 into 2 plus 6. This will be 8 minus 14 plus 6. This will be 14 minus 14, which is equals to 0. What happens if we place 2 minus 2 instead of 2? R is equals to minus 2. So R of minus 2, x will be equals to minus 2. So R of minus 2 is equals to minus 2 whole cube minus 7 of minus 2 plus 6. This is minus 8 plus 14 plus 6. This will be equal to 20 minus 8, which is 14. So when you placed one value of x, you got a numerical 0. But when you placed another value of x, you got a non-zero term. Here, 0 is the value of t of x at x is equals to 2. 0 is the value of r of x at x is equals to 2. 14 is the value of r of x at x is equals to minus 2. So you won't get the numerical value 0 for all the values of x, but you may get a 0 sometimes. So this is at a point of discussion over here. If you have a polynomial q of x is equals to ax square plus bx plus c, and if you place an x value, let's say that x value is d in this equation, and if you get a numerical value 0, so at q of d, if you're getting a 0 value after placing x is equals to d in this equation, if you get a 0 value, then this value of x d, then this d value is said to be d is the 0 z0 0 of q of x. So from the above discussion, we can say that for values x is equals to 2 in t of x and x is equals to 2 in r of x, we are getting a numerical value 0. So यहाँ पर in this case 2 is the 0 z0 0 of t of x. Here 2 is the 0 of r of x. Here minus 2 is not the 0 of r of x. Which brings us to the next question. How many zeros can a polynomial have? How many z0 zeros can a polynomial have? So if your polynomial p of x is a linear polynomial, then it will have degree 1. The number of degrees of a degree, or the degree of a polynomial, is equal to the number of zeros of a polynomial. So if your degree is 1, you will have 1 0. Number of zero of such a polynomial will be 1. For a quadratic polynomial, your degree is, just understand that this is polynomial over here. For a quadratic polynomial, your degree is equals to 2. Therefore, number of 0 will be 2. 2 plural zeros is equals to 2. That means there will be 2 values of your variable x, which when you put in p of x, you'll get the digit or numerical 0. Cubic polynomial, your degree is 3. Hence, number of zeros will be 3. Biquadratic, degree is 4. Number of zeros will be equal to 4. Constant polynomial. Now we know that in a constant polynomial, your degree is 0. Your degree is 0. Hence, number of zeros will be 0. Now this constant polynomial has an exception case. Constant polynomial except for zero polynomial. Do you remember zero polynomial from the last class? Let's revise it quickly. So t of x is equals to 4. This is a constant polynomial. R of x is equals to 5 or minus 5. This is a constant polynomial. But if I write q of x is equals to numerical 0, then this is a zero polynomial. So for these two values, when you have constant polynomials, your number of zeros will be 0. Here, you will not have number of 0, 0, but number of zeros could be any real value or every real number. So it has infinite roots or infinite zeros. Roots is another synonym of ZERO zeros. I'll write it once again. Every real number. Zeros are also called as roots. So instead of saying zeros of a polynomial, you can also write roots of a polynomial. So it has a linear polynomial has one root, a quadratic polynomial has two roots, and so on. Let's consider one more example. Let us consider s of x as x cubed minus 2x squared plus 3x. And another example, t of x is equals to x squared plus 13x minus 30. By observation, here s of x can have three roots or zeros. T of x will have two roots. We're not calculating all roots, we are just taking random values of x first. So if I take x is equals to 0 over here, this is the number 0. X can have the value 0. So s of 0 will be equal to 0 cube minus 2 into 0 square plus 3 into 0, which will give you a numerical value 0. What if you place 1? X is equals to 1. What will happen? You will get 1 cube minus 2 into 1 square plus 3 into 1, which is equals to 1 minus 2 plus 3, which is equals to 2. What if you place x is equals to minus 1? So s of minus 1 will be equals to minus 1 cube minus 2 into minus 1 square plus 3 into minus 1. This is equals to minus 1, minus 2, minus 3. What happened? Minus 2, minus 3. This will give you minus 6. So you can easily say that 1 and minus 1 both are not the zeros or not the roots of the given polynomial s of x. 0, however, is the root of s of x. So we can say that 0 is the root of s of x, and 1 and minus 1 are not the roots of s of x. Next, let's consider this example on the next page. This one. So t of x that we considered is equals to x squared plus 13x minus 30. Let's put x is equals to 2. What do you get? T of 2 is equals to 2 square plus 13 into 2 minus 30. This is 4 plus 26 minus 30. So 30 minus 30, which is equals to 0. What if we place x is equals to minus 2? T of minus 2 will be equals to minus 2 whole square plus 13 into minus 2 minus 30. 4 minus 26 minus 30. This is equals to 4 minus 56, which is minus 52. We can see that 2 is the 0 of t of x, but minus 2 is not the 0 of t of x. By this, from these examples, we can conclude some things. 1. A 0 of a polynomial need not be 0. A 0 or root of a polynomial need not be 0. In this example, 2 is the root, which is a non-zero value of the polynomial. Here, 0 is the root of the polynomial, which is a 0 value. In these examples, 2 is the root, 2 is the root, which is a non-zero term. So you may have 0 as the root of the polynomial, as in this case, or you may not have it, as in the other examples. Next. A non-zero constant value has no zeros, and every real number is a 0 of the 0 polynomial. This we've already seen, that a non-zero constant polynomial, these are non-zero constant polynomial. Non-zero means not equals to 0. Non-zero constant polynomials, and this is a 0 constant polynomial or a 0 polynomial. So non-zero constant polynomials will have 0, number of zeros is 0, and here you have every real number as its zeros. So this concludes this chapter. We will discuss further introduction about the chapter in the next class. Thank you.